Good morning, this is Dr. Reveles and this is with a video about momentum rocks collision. So let's see, we have a rock here, rock 1, who is moving straight right with a speed of 10 meters per second. And incoming rock number 2, it's moving in this direction, but now at an angle, and with a speed, rock 2 has a speed of also 10 meters per second. The difference is that rock 2 is at an angle. Let's see an angle here, where the angle in a given problem is 60 degrees. Question is, as the two rocks approach, they have a collision, 1 plus 2, and now they are moving together. Question is, what is the final velocity of the two rocks? Well, let's see. Let's find first velocity components. So V1, we can say is a arrow that coordinates are 2, 10, 0, because it's pointing straight right. While V2, we need to do some more work because it's an angle, has two components. Let's say V2x is pointing left, and V2y is pointing down. Okay, so the components of this V2 vector will be B cosine of the angle, V2 cosine of the angle, that will be Bx, and V2 sine of the angle. However, notice that this arrow is pointing down, is in quadrant 3. This arrow is in quadrant 3. So I'm going to notice that I need to add a sign here that this Bx is negative and By is negative as well. Okay, so V2 is going to be then negative 10 cosine of 60 degrees and negative 10 sine of 60 degrees. So after doing the calculation, we say V2 equals negative 5 and negative 8.7. Okay, now I have the components of the two arrows, V1 and V2. So what we need to do next is do a balance of momentum. So balance of momentum. But we want to do this balance of momentum twice because we have two directions, x and y. So let's see, for the x component, we can write the balance of momentum as the full equation, mass 1 v1 initial plus mass 2 v2 initial equals mass 1 plus mass 2. Remember that the two rocks stick together, v final. We call this a perfectly inelastic collision. After the collision, they stuck together. Let's substitute. So mass 1, you say mass 1 is 5 kilograms and mass 2 is 10 kilograms. Let's see, mass 2 is 10 kilograms. So substitute this. So mass 1 is 5 kilograms times V1. Remember that we are focusing now on the x component. The x component and the x component of the two arrows. So V1 times 10 plus mass 2 times V2, which is negative 5, equals mass 1 plus mass 2, total mass V final. You can see that this is going to cancel out. 50 minus 50 equals 15 B final. We are looking for B final. And B final in this case is 0. So they do cancel out the x component. This is 0. Okay, let's do now for the y direction, y component. So for the y component, we have y component, exactly the same equation, but now we're going to use the y component. This is the y and this is the y. So let's write again the equation. So mass 1 times B initial y plus mass 2 B initial equals total mass B final. Let's say B final. Okay, what this will be then will be negative 87 equals 15 times B final, and then V final is negative 5.8 meters per second. So now we have the components of the final velocity, which I'm going to say this is the final velocity in the x direction, this is the final velocity in the y direction. So let's say P final is going to be 0, negative 5.8 meters per second. This is this final velocity, which I'm going to draw in blue. Final question will be, what is the speed of these two rocks together? We want to use Pythagorean theorem, which is B final x squared plus B final y squared, square root of this. So we substitute, will be 0 squared plus negative 5.8 squared, don't forget the parentheses, and that will give you a final speed of 5.8 meters per second. Okay, thank you for watching. Let's review. Okay, let's review finally before we go. Two rocks coming together. Here is a collision, happening the collision here, and the final velocity is found by doing a balance of momentum twice, once for the x direction, once for the y direction. You find B final in the x, B final in the y, which is your here, and Pythagorean theorem gives you the final speed. Okay, thank you for watching. See you next time.